Good day everyone, I am Alamay Ayaki from BSCS4A and I will be discussing about building a K-means clustering model.
The code imports necessary libraries like NumPy, Pandas, Matplotlib, and scikit-learn for data analysis, visualization, and machine learning. It then loads the iris dataset, storing the feature data in X and the true labels in Y. The code standardizes the feature in the dataset using the standard scalar, ensuring they have a mean of 0 and a standard deviation of 1. This pre-processing step often improves the performance of machine learning models. K-means clustering is an unsupervised machine learning algorithm that groups similar data points into cluster. It works by iteratively assigning data points to the nearest cluster center and then updating the cluster center based on the assigned points until the assignments stabilize. The code k-means n underscore cluster equals 3 random underscore state equals 42 creates a k-means model that will group data into 3 groups with the initial groupings based on a specific starting point. The code takes the cluster data and make it easier to visualize by reducing it to 2 dimensions. Then, it plots the data points and the center points of each cluster to show how the data is grouped. The plot shows the result with the k-means clustering on the iris dataset. Each data point represents an iris flower, and the color of the points indicates the cluster it belongs to. The red X marks represent the centroid of each cluster, which are the central points of the cluster. As you can see, the k-means algorithm has successfully grouped the data points into 3 distinct clusters. The clusters are well separated, and the centroids accurately represent the center of each cluster. This visualization helps to understand how the k-means algorithm works and how it can be used to group similar data points together. This activity applies k-means clustering to the iris dataset, a popular dataset in machine learning. The goal is to group the data points into 3 clusters based on their features. Before clustering, the data is standardized to ensure each feature contributes equally to the clustering process. After applying k-means, the cluster labels are assigned to the data points, and the centroids or the center of each cluster are calculated. To make the results easier to visualize, the dataset is reduced to 2 dimensions using PCA or Principal Component Analysis. Finally, the clusters and centroids are plotted in a 2D space, providing a clear visual representation of how the data points are grouped and where the cluster center lies.
And that concludes my video presentation. Thank you for watching. Bye!